right, so this is the recording for Force and Motion, lesson 2.3. Real quick, if you're wondering why we're already on 2.3, we skipped 2.2. We kind of squished them together so that we can do something outside of Amplify later on this week, and more to come on that. But this lesson, we are continuing our investigation on how the mass of objects can affect the force and velocity. And the first thing that we did was a warm up in Amplify. And in this warm up, it presents a scenario that we will investigate in the simulation. But before investigating it in the simulation, it wants us to make some predictions. So in this warm up, you see there are two objects, A and B. And we can tell that they are both in motion because of the blue velocity tails coming off the end of them. And so the two predictions we have to make before we actually test it out in the simulation is, if our goal is to make these objects slow down, which direction should the force be applied? And so you're going to click from the drop down menu here, up, down, left, right. And so we know that these objects are already moving to the right. And so which direction should these forces be applied to get it to slow down? And then the second thing is object B is more massive than object A. So object B has more mass and weighs more than object A. If we apply the same force to them, so 4 clicks to both objects, which one is going to have a greater change in velocity? And so you're going to pick object A or object B. And like I said, now that we've made these predictions, we're going to test it out using the simulation and see. Here we have the instructions. So once that simulation is up and open, you are going to click the menu and you're going to click 2.3 warm up, which sets up our scenario for us with our two objects. And then, I keep moving myself around here, you are going to run it. And I'm going to kill two birds with one stone by doing the same force on both. So I'm going to do 4 clicks and I'm going to do it in the opposite direction. So my objects are moving to the right. I'm going to apply force to the left. So 1, 2, 3, 4. 1, 2, 3, 4. And you're looking for if the objects slow down, and you're also looking for which object has a greater change in velocity. And I noticed that object A had a greater change in velocity. It ended up stopping completely. So that was object A, and then applying a force in the left direction helped it slow down. I couldn't really stop object B because it was heavier, but it did slow it down a little bit. And the next thing that we did after the warm-up is we did the reading. And so we skipped lesson 2.2 because lesson 2.2 was pretty much just this reading. And since lesson 2.3 had you reread it, we just are going to have you read it once. And so down here, once you scroll down, you're going to see that there's an article titled Designing Wheelchairs. And this has to do with our topic because they talk about masses of wheelchairs and how there are different wheelchairs for different functions. Obviously, some people can't walk, so they use a wheelchair to get around, but some people who also can't walk or have issues with mobility, they have them for playing basketball, racing, rugby, all these different things. And so you're going to see the article pop up here. What you're going to do is you're going to highlight it. So you're going to highlight it with any important information that you find. And the ideas that we're focused on, you can see down here, there are 3 questions that you're going to answer once you've read it. And so you're going to look at which wheelchair would be more difficult to stop, a more massive one or a less massive one. And then if the same force is exerted on both wheelchairs, which one's going to go faster? And then how you would design a wheelchair for a basketball player. And so when you highlight, make sure that you are highlighting important information and kind of focus on mass and velocity. do the wheelchairs made for racing have a greater mass, a less mass, and kind of focus on how mass affects the movement. Does it make it go faster, slower? What is that all about? And so that is activity 2. And then we did activity 3 together a little bit. And so activity 3 has us modeling our 2 claims. And so we have our 2 claims, which I will show you here in a second, that we have been looking at throughout the unit. And so our first claim is that the thrusters cause the pod to move in the opposite direction. And then we had that it only slowed the pod, so it ended up bouncing off and then going the opposite direction. But now we have incorporated mass into this statement. So we were looking at these before, but we didn't think about mass. I remember we're thinking about the amount of samples that are on each space station and wondering if that affects its velocity, if it's heavier or lighter, and so on. And so down here, you're going to notice there are 2 pages, so we are modeling each claim. So page 1 is claim 1, and then page 2 is claim 2. So I'm going to click on that link, and that link is going to bring me to the modeling tool. So I just clicked right there. And this will load up the modeling tool, and I'm going to model claim 1. So here is our modeling for claim 1, and the top row is modeling what is supposed to happen. So we have our object coming in at a medium speed, and then a force is acted on it in the opposite direction, causing it to stop. But what we need to model is we need to model the pod's mass so that the usual force would cause it to move in an opposite direction. So the first thing we need to think about is which of these masses, and we're not going to use B because B is our normal size. We're going to look at A or C. Which one of those would cause it to be easily moved because it is acted on with the same force, but instead of stopping, it gets pushed in the opposite direction. And so we kind of had a class discussion about how object A is lighter, so it would be easier to change its velocity. So there I have my object A going in at medium speed, and then my object A being acted on with a medium force in the opposite direction. But instead, this time of stopping, it ends up going in the opposite direction. So I'm going to put it going in the opposite direction. So that shows that scenario. And then at the top here, you click hand in, and that will plop it into the assignment for you. And then there is the page 2 down here. And on that page 2, you are going to, down here, see that we are now modeling claim 2, and it's a different modeling tool. So you're going to want to click this hyperlink, claim 2, chapter 2, and load that up. And then same thing as before, the top is showing what should have happened. So it's going to be the same scenario as before. Medium speed, getting an opposite force acted on it and stopping. This time we are going to model the second claim, which has it show that the thruster only slows it down so it doesn't stop it, causing it to hit the space station and bounce off. So thinking about what we did last time, we had a lighter object. So this time the object would need to be heavier because that force could not act on it enough. And so my object C is moving at medium speed. My object C gets acted on by a medium force in the opposite direction. And then my object C, instead of bouncing off, it's only slowed down, and so then it will bounce into the opposite direction. And then you can click hand in, and that will plop it into that assignment. And that is all for Amplify. You are not doing the homework, so you are completing 1, 2, and 3 and making sure those were handed in Amplify. In Canvas, there was an exit ticket that you needed to do. And then in your Force and Motion notebook, I had you guys doing the notes for 2.2 and 2.3. So here is the page for lesson 2. Remember, we skipped this one, but there's still important ideas that we need to know because this went along with the article. And so those 2 important ideas were that wheelchairs built for stability, not speed, have a greater mass. This means the wheelchairs change velocity less upon impact with other wheelchairs. And they kind of gave this example in the article about how rugby wheelchairs need to be more stable and a little bit heavier so that they don't get knocked over when they collide. And then the other one is wheelchairs built for racing have the lowest possible mass. This way the wheelchairs can change velocity as much as possible when the rider exerts a force on them. So they need to be light and quick. And then lesson 3, this was kind of what we got out of the modeling tool. The idea is that if the same strength force is exerted on 2 objects, but the objects have different masses, the object with the less mass will have a greater change in velocity. And so the lighter the object, the easier it is to make it move, so it will have a greater change. And that is that for today.